Hello to everybody. I'm going to present you introduction for beginners about the Network Simulator 2, and I hope it will be interesting. So let's see what is NS2. NS2 is a network simulator. It is discrete event simulator. It covers multiple layers: application layer, transport layer, network layer, and link layer from TCP/IP model. It supports the simulation of in-service, diff services, multicast transport application, wireless, fixed mobile, and satellite. It goes on packet level. What does discrete event simulation means? It means that this simulator has a list of events that it executes them one by one in some ordered simulation time. It processes the beginning one, afterwards it takes the next one, run it until it's done. So it goes to the other one, to the other next event. So each event happens in an instant of virtual simulated time, but it takes an arbitrary amount of real time. So NS use a simple model, single thread of control, no locking or race condition to worry about. It is very easy. It is developed in 1989 for the DARPA project. Afterwards it was upgraded by a lot of research laboratories from some respected universities and companies. The first initial version was NS1. Today we are using NS2. The current version is NS2.35. It has a lot of number of lines, of code line in C++, in OTCL. It has a lot of test suites and a number of documentation that for beginners it's quite difficult to be followed, especially if you have lack of experience in C++ and OTCL. So what is, like I said, it's object-oriented simulator written in C++, and OTCL, it is object tool command language. It is interpreted as a front end. The back end is C++. It is used to define new agents, protocols, and frameworks. If you have to change some behavior of the existing C++ class, then you have to go in details in the back end and to make the wanted changes. It is for people that are not just creating simulations but want to design some new model, new transport protocol, new agent, and so on. So the front end, OTCL topologies. OTCL is used to create topologies, scenarios, and simulations. It is a script language. It allows you to create easy topology modification and so on. It gives you a chance to do what you want by manipulating the existing C++ objects. So why two languages? C++ is fast to run but slow to change, and OTCL runs much slower but it can be easily changed. So it is a combination in order to have a smaller processing time. This is how can be described. You can see that you have some pure C++ objects on one side. On the other side you have some pure OTCL objects, and how they are correlated. There are C++ slash OTCL split objects, and all together they create the network simulator NS. This is how the directory structure is presented. You can see that NS all-in-one is consisted from all of these directories. You have TCL directory depending on the version, and here you have it's labeled as X in order not to predefine some actual version, because all structures of all these variety of simulators versions are the same. So if you use network simulator NS2.31, it will differ in the number of the TCL directory and normally in the procedures that are included and the possibilities that it enables to you in order to simulate the requested environment. But in NS directory structure, this is the only change. So that's why I have labeled with X in order not to make some confusion. For example, if you have the NS 2.35 network simulator, the same directory structure will be kept. So you have TCL directory, you have TK directory, you have OTCL directory, TCL, CL directory, NS2 directory, NUM directory. In NS2 directory, you have are consisted the C++ codes and the objects are put in there. You have their subdirectory TCL, in which examples are in example scenarios can be found in the X directory. There are some validation tests that are in the test directory. There are some libraries that are put in the lib, and so on. As you can see, it is not a difficult structure to and can be easily used. This is a network topology node because you are going to use them a lot, so it will be nice to know them. The classifier allows you to address multicast, multipath, and hash. So you can see one unicast node and one multicast node. What is the difference? You can notice it here. You have address classifier, port classifier. You have demultiplexer on the both sides, and this is how the network topology link is created. All of these are parts of it. We have to mention that we have simplex links and duplex links, and duplex link is maybe created by two simplex links that carry traffic from one to the other side, and vice versa. This is how the routing is done. Yes, you can notice that we have to create above the node. We can create agent. We can create UDP or TCP agent. At the receiving end, we have to define a sync agent. It can be TCP or UDP null agent. Above the TCP, you have to define application. In this case, file transfer protocol (FTP). In case of UDP, you have CBR or similar application above. This is how with blue is denoted the TCP packet, and with red line is denoted the acknowledgement. So you can see this is the root of the TCP packet through the link. At the receiving node, you see that the address classifier tells that you have 1, and it should be proceeded to port 0 to the TCP sync. Who create this? It defines the destination is defined by address 0 and port 0. So you can see the red packet, the acknowledgement, how it goes through the link, comes to the address classifier. It goes to 0, and it proceeded to the port classifier, to the right port classifier. So what we have one OTCL script that contains all the details that should be created, the topology, the schedulers, and so on. It is run by NS, and it generates simulation result, mainly put in trace file. Previously, you have to define all the details. The trace files continue all the resources and the information needed in order to create the requested analysis, you can define num files in order to see the packet flow in the simulation scenario, or you can, with help of these trace files, you can create graphs. So these are the resources that could be used in order to start with the network simulator. So we have seen what is NS, and we have seen the basic NS2 structures. This is the basic syntax for the TCL. TCL commands are evaluated in 2 steps, like you see. First, the TCL interpreter parses the commands into words, performing substitution along the way. Then the command procedure processes the words to procedure result a string. Each command has a separate command procedure. So this is how it is done. This is the TCL basics. TCL basic, you have command 1, for example, and several arguments. The command is either name or built-in command of or TCL procedure. Argument grouping, variable substitution, command invocation. This is the first example, hello world. You can see the details. Several examples how to set variable a value, or how to yes, you have to execute them in order to see the results in NS. Variable substitution, how is done, please try it. Command substitution, how is done, please try it. Operation substitution, you can see wrong numbering. Invalid command, you can see the right answer, how is presented. So just write TCL code and execute it in NS, and you'll have these commands. In our next example, I will show you how it's done detailedly. This is how the grouping is done. I'm not going to go in details. If you want to try it, go ahead. Some control structure, if condition, then execute something, or some for loops. For example, you set some parameter value and it goes up to some value, what to do? Execute it. Some procedures, how are done. This is the example. You can execute it, please try it. And results. OTCL basics, you can see that you have to know how to create a class name, superclass, child class, parent class, and so on. You have to define instance procedures. This is how it's done. Defining instant variables. This is how it's done. You will see it's nothing scary. These are just the basic that you should be familiar with, in order when you're going to see a code to know what is what. Creating an instance. This is how you have to create an instance. Every TCL script will start with creating an instance, calling the instance, and using the instance value. Example of classes. You can create class mom with all these characteristics. Afterwards, you can create class kit. Yes, this is the OTCL code. Afterwards, you will set the instance. You give adequate value of the variable for the both of the procedures. Yes, for the both of the classes, and you call them. After you call them, and the result, they will execute, and this is the result that you will obtain. So, elements of simulation, you have to create event scheduler, order of executing. You have to turn on tracing. You have to create topology. You have to create transport connection. You have to create traffic on top on the transport connection. So, for example, if you analyze this dumbbell topology, network topology, with all this specification of the links, NO is TCP source, N3 is TCP sink or the destination, N1 is CBR UDP traffic, and N2 we implement loss monitor. So you have to create event scheduler. you set new NS, new simulator, you afterwards schedule the events and which time what will happen. For example, NS at time FTP start or FTP stop or CBR start or CBR stop event. So you have to define some event to happen. And at the end you have to start the scheduler with NS run. So this is the tracing. You have to create the tracing files after your in order to keep track for all events that are happening in your simulation. This is done with the command ns-trace all. You will open in the brackets, it says open test.out. With this command you will open the test out file for writing, and in which all the details will for all packages that are in this simulation will be remarked. So the trace file will give you information about the event, time, from which node it goes, the packet size, and so on. A lot of identification fields that could be used afterwards for some analytics. Trace packets on all links in num format. In order to be able to see in a network animator tool, you have to implement this command. For example, ns-namtrace all. You will do this in test.num file. With the open command, you will open it for writing, and you will write all the details here in order to be able to present the simulation in num. So you must all these commands must appear immediately after creating the scheduler. Do not forget the scheduler. So you create it, and afterwards you put all the trace files, all the trace command in order to open the files to store the information there. So tracing, these are the commands that should be put in. You can trace the information that is stored in the queue between the node N0 and N1, and you can num trace also the queue. This is how it's done. So it's quite easy. You have to create in order to create the network, you have to create the nodes. At the beginning you have to create the node 1 and node 0, node 1. You have to create the link. For example, NS create duplex link. Here you can substitute this with simplex link if needed, but all links are duplex, so you should use duplex. This is the link between which nodes is created. You will define the bandwidth, the delay of the link, and the queue type. The queue type can be droptail, red, CBQ, FQ, SFQ, DRR. It is queuing mechanism that can be used. Droptail is the most common to be used, but there are more advanced are red and the others. So if you need, just change them. So you can see that how nodes are created. Yeah, you have 6 nodes here, from E0 up to 6, increase C and set N E NS node. After we are creating the nodes, we are creating the links with all the details previously discussed. We can set the queue limit between N4 and N5, or between any two link nodes on some value. In this case is 20 packets. So create transport connection, TCP. You have to create a TCP agent and to attach it to node NO, because in this case we have defined it like that. So you have to set up connection between node NO and N3. For example, we are creating the new agent. We are defining the protocol, it's TCP, and we are defining which TCP it will use. Here we can put a SAC or some other version of the TCP. So you're attaching the agent with the TCP source. Yes, this could be variable. Yes, to name it like you want, but it should be kept the same here. So you are defining afterwards the destination agent. It's a new agent, it's a TCP sync. It uses this class. All parameters that are defined in TCP sync will be used, and this is the mechanism delacka that will be used. Without this, it's not going to activate the delay acknowledgement mechanism. So you are attaching the agent at N3 and connect them. This is must do. In our next simulation, we are going to see how it's done in the code. We are defining the UDP. We are creating new UDP agent. It defines the type of the. We are defining the traffic. It's UDP. We are attaching the agent, like we said. It's N1. So we are setting the destination here. It could be null instead of loss monitor. We are attaching it and connecting. So above, on top of UDP, we can create constant bit rate, CBR traffic. We are defining it with send CBR, new application traffic CBR. We are attaching this agent with the UDP. We are defining the type CBR. We are defining the packet size. In this case, it's 512 kilobytes, and we are defining the CB rate. This packet size and the rate, you can adjust them at the value that you want. You can use also Pareto or exponential traffic instead of CBR. This is how it's done. So FTP must be defined above TCP, and you are attaching them. You also define packet size, and you are defining the time when to start to generate the traffic. Telnet can be also defined. So what do you have to remember? You have to remember that you have to create topology, agent, sources, and start and end time. So connect the agents. If they are not connected, you will receive an error. Stop the sources. You have to have procedures to define them. If they are not defined previously, to declare some global variables before use. Every variable must be defined previously. So at the end, you must to write NS_run in order to run the simulation. So visualization tools are network animator and Xgraph. Xgraph used to generate graphs. This is all. I wish you pleasant simulations. Hope you will have successful research.